Scalar multiplication. So today we're going to be multiplying matrices by scalars. And it turns out that whenever you have a number outside your matrix, like let's say k in this example or 3 in this example, what you're going to be doing is you're going to be multiplying every single number inside the matrix by whatever number is on the outside. So for this, what I would be doing is I'd be multiplying k by every single letter on the inside. So the first thing I would do is I would multiply k by a. And when I do that, I get ka, k times a. Then I'm going to move on to the next element of the matrix. I'm going to multiply k by b. And when I do that, I get kb. Then I move to the bottom row. I have k times c. That's going to give me kc. And then I'm going to multiply k by d. When I do that, I get kd. So that finishes up the matrix, and then I close it up, and then we're done. So basically what we're doing is we're multiplying every single number in the matrix by whatever number is on the outside. So looking at this one, I would multiply every single number on the inside by 3. 3 times 4, that's going to give me 12. 3 times 2, that's going to give me 6. So that's the top row. On the bottom row, I'm going to have 3 times 5, that's going to give me 15. And then I'm going to have 3 times negative 1. That's going to give me a negative 3. So every single number on the inside has to be multiplied by whatever number is on the outside. So looking at two different examples, we have negative 10 times every single number in this matrix, and then down here we have 0 times every number inside this matrix. So up here, we're going to multiply everything by negative 10. When I do that on the top row, I'm going to have negative 10 times 2. That's going to give me negative 20. I also have negative 10 times negative 3. That's going to give me positive 30. Second row, I've got negative 10 times 6. That's going to give me negative 60. And then 1 times negative 10 will give me negative 10. And then on the bottom row, anything times 0 is going to give me 0. So I'm going to have 0 right here. And then for the last element, I have negative 7 times negative 10. That will give me positive 70. Down here, since I'm multiplying everything by 0 on the outside, I'm going to have an entire 2 by 2 matrix with all entries 0. So I'm going to have 0, 0 for the top row, and I'm going to have 0, 0 for the bottom row. Now, every single matrix that only has zeros is called a zero matrix. So this is called the zero matrix. And sometimes we use the symbol 0 with an arrow over it. It's called the zero matrix, or sometimes it's called the zero vector. The zero vector.